Hey there, seventh graders. Today, on this final day before we get to take a break, we need to review something that I feel pretty confident that you've seen before, but is going to really help us with our proportion problems. So up until this point, we have we've found the unit rate or found K, the constant proportionality. We've written an equation, we've defined our variables. This is an excellent algebraic process to help us. Today we're going to learn that there is maybe a little bit of a shortcut, maybe. But first we have to review something called cross multiplying. So get out your notes, get out your pens and pencils, and here we go. All right, these notes are called What is Cross Multiplying? And this is what they look like. You guys have your paper and your pens in front of you. I'm gonna do my best to write on the screen here. So it says up here on the top, write another ratio that is equivalent to the given ratio. Remember, equivalent means looks different, but actually has the exact same mathematical value. So I could do anything. I could multiply this. You could simplify it if possible, but it's not. 3/4 is simplified. So what I can do is multiply it by anything really. Like if 3/4 is equivalent to, I know if I just double it, then 3/4 is equivalent to 6/8, right? 3/4 is equivalent to 6/8. Now it says here, now multiply each numerator. Remember, that means the top number in a fraction. Multiply each numerator by the denominator in the other fraction. Okay, what do they mean by that? Let's take a look. So if I do, here's the numerator and here's the denominator in the other fraction. So if I multiply these, 3 times 8, I'm going to do 3 times 8. And I'm going to do 6 times 4. If I multiply the numerator by the other denominator, do you notice anything about those products? What's 3 times 8? And what's 6 times 4? Oh my goodness, they are equal to each other, right? 24 equals 24. Did that just happen to happen on that one? Or is that a thing that always happens? I don't know. Let's check it out. So look at this one. This one says 18/15. Now that one actually can be simplified. I could still multiply it if I wanted, but if I want an equivalent ratio for that one, I could just simplify those. So these are both divisible by 3. 18 divided by 3 is 6, and 15 divided by 3 is 5. So I could say, okay, 18/5 is equivalent to 6/5. We agree that those are equivalent, right? Let's see what happens if I do this again. 18 times 5. Okay, I'm going to write that down here. 18 times 5 and 15 times 6. You can go ahead and type those in a calculator if you need to. 18 times 5 and 15 times 6. Okay, 18 times 5. Did you get that? 18 times 5 is 90, and 15 times 6 is 90. Oh my goodness, those are equal as well. And I'm going to tell you this, if you start with two ratios that you know are equivalent, okay, if you start with two ratios that you know are equivalent, then this is going to happen every single time, just in the nature of equivalent fractions. So this idea of cross multiplying, which is also known as cross products, because products is a word for multiplying, right? Product is the answer to a multiplication. So cross multiplying says to us, if I have a ratio, we'll call it A over B. So I'm going to write this. If, okay, it starts like this. If A over B is equal to C over D. And they're all 4 different variables because look, they could easily be all 4 different numbers. But the fact is, the key here is that we started by knowing those two ratios were equivalent. So all this is saying right here is, if you start with equivalent ratios, if you know that these ratios are equivalent, I'm going to put comma, then here's what we know is true. If I do this times this, which is A times D, right? If I have an equivalent ratio, then, and I'm just going to write it the way a mathematician would, if you just put A and D right next to each other, that means multiply, right? So if A over B is equal to C over D, if I have equivalent ratios, then I know that A times D is going to be equal to, what's the other one it's going to be equal to? Oh, this one across here. This is why it's called cross multiplying, because you do the numerator of one times the denominator of the other and the numerator of one. So A times D will equal B times C. And this is a property that's just true because of equivalent ratios, the way it works. Always, if you set equivalent ratios to each other, if you multiply across like this, those two products will be the same. This is going to be a really handy thing to help us solve some proportions. Okay, so make sure you have all that written down because I'm going to clear all this writing away. So you get it all. If you need to pause me or go back, you can, but I'm going to clear all my drawings and then we're going to move on. Okay, so if I scroll down here, I think I have to change this to a mouse. I know how computers work. Okay, so now we're actually going to use that idea to help us solve these proportions. Okay, so if I have an equation that looks like this, if I have a fraction equal to another fraction, do you know what they're telling me to start off? They're telling me that A over B equals C over D. They are telling me right here, this equal sign in the middle says these are equivalent ratios. Cool. If I know that they're equivalent ratios, guess what? I can totally do this. I first need to make sure I'm on drawing format. And then I can totally do this. I'm going to say this times this, which I could write x times 50, but the way a mathematician writes that is they always put the coefficient first, right? 50x equals this times this, whatever 5 times 36 is. Okay, so this part I can't actually multiply right now since one's a number and one's a variable. I don't know what x is, but that's the whole point here is I'm going to use the fact that these are equivalent ratios and the fact that I can do cross multiplication to solve this. So this side though, I can do the math here. 5 times 36, let's see, I don't have a calculator in front of me, but 5 times 30 is 150 and 5 times 6 is 30. So 150 plus 30 is 180. 5 times 36 is 180. I'm sure you guys will let me know if I make a mistake. But you could type that in a calculator. 5 times 36 is 180. Now here's the deal. This equation now here, so this one that we started with maybe doesn't look super familiar to us. Maybe we're not 100% clear on how to solve that. But this equation right here, oh, we definitely know how to solve that, right? We've solved stuff like that a whole bunch of times. So if they are multiplying, I want to isolate the variable, so I am going to divide by 50, divide by 50. And 180 divided by 50, go ahead and type it in your calculator. I'm just thinking 18 divided by 5, 5, 10, 15, that's 3. With 3 left over, 3.6. You guys can type it in and verify and let me know if I got that. But the fact is, in its equivalent ratios format, we didn't quite recognize how to solve that because, I mean, you could use equivalent ratios. Do you see this right here? 50 divided by 10 is 5, so I could just divide this by 10, which verifies that 3.6 is the correct answer. But in equivalent ratios, you can't always see what it's going to be. But if you cross multiply, then we can just use the skills we already have to help us get there, right? Okay, so let's try this again. Let's look at number 4. So take a look at number 4. Okay, so on number 4, once again, the fact that there is an equal in the middle tells me that these are equivalent ratios. And knowing that I have equivalent ratios means I can do this. And I don't even always write down like 48 times 15. I just type it in and go, okay, 48 times 15 is 720. I know I'm multiplying those. So I'm going to write 720. That came from 48 times 15. And because these are equivalent ratios, I know I can put an equals in the middle. A times 12 is 12A. So I multiplied those, and I put an equal in the middle because that's what the cross products property says I can do because they are equivalent ratios. We getting that? All right, and if I want to solve for A, which I absolutely do, now I simply go divide by 12 because that is the one on the variable side. That turns to 1. And 720 divided by 12, well, 72 divided by 12 would be 6, right? So 720 divided by 12 is 60. What we are saying here is we are saying that 48 over 12 is equal to 60 over 15. That's what we're saying, is we found the value of A that makes these ratios equivalent, because that's what the equation wants. Well, let's check that. Does that make sense? Yeah, it does, because 48 divided by 12 is 4, and 60 divided by 15 is 4. So we found the correct value that makes that ratio true. All right, let's do a couple more together. So take a look at number 5. Here's what we are saying. We are saying that 20 times y and 18 times 12. 18 times 12 is 216. Because these are equivalent ratios, these cross products are equal. That's what we know, and that's what we can use to help us solve problems. So because these ratios are equal, 20 times y is equal to 216. And now we can just solve this basic equation. Divide by 20, divide by 20. 216 divided by 20, y equals 10.8. And once again, what we're saying here is we found this number that goes right here in this ratio. We're saying 10.8 over 12 is equal to 18 over 20. Well, how can I verify that? Because that one's not dividing nicely like this one did. Well, I could change these all to decimals. 10.8 divided by 12. If I type that in my calculator, this one says 0.9. And guess what? 18 divided by 20 is also 0.9. So it works. We found the correct value that makes this an equivalent ratio. We use cross products to help us finish the equivalent ratio. Is this making sense? So let's try one more together. Here we go. I know that 2 times 16, which is 32, and 32w, I know that those are equal to each other because these are equivalent ratios and those are cross products. So we are going to now divide by 32, divide by 32, and we are finding that w equals 1. Let's go back and see if that makes sense. Is 2 over 1 equal to 32 over 16? Yep, sure is. Okay, so we found the other piece of the ratio that makes this a proportion or makes those equivalent ratios. Okay, I'm about to clear all this writing, so make sure you have it. Otherwise, if I scroll down and the writing's all still there, then it stays in place and the page moves and it looks really weird. So do you have everything? If not, you can always go back in the video, pause and write things down. What you guys are going to do now is you guys are going to try the last 2 problems. Everybody try 7 and 8. Go ahead and pause me right now. Cross multiply, solve for G, solve for B. Go ahead, pause me. Ta-da, let's see how we did. Number 7, whoa. Number 7 came out nice and even. Everything worked out. Number 8 didn't. And that's okay. I had to round. That happens sometimes because sometimes in order for these 2 ratios to be totally equivalent, sometimes it doesn't come out even. And that's okay. It happens. So cross multiplying is going to be a very, very handy skill for us for lots of things that we're going to do moving forward. So if you have any questions at all, or if there's any of this that didn't make sense to you, please, please ask.